Okay, today we're going to talk about the second day of talking factoring by grouping. Last time we factored by grouping with two terms. Remember, we gathered two terms. Today we're going to be gathering three terms, but we talked about this before, haven't we? When do we want to gather three terms? When you have four-term polynomial, when they are PST, and when you have perfect square trinomial, and then when that becomes difference of square. Remember? So we're going to be group them by group. If you have four terms, there are times where you want to group them by twos. Today we're going to talk about when we want to group them by threes. Does that make sense? And of course, those three terms will be perfect square trinomial, and I refer them as DNA onion problem. You guys remember that? Yeah, we did this before too, right? So should be pretty familiar with these. So we need to review what a PST is, right, and what the difference of square is. So if you have PST, perfect square trinomial, how do we get perfect square trinomial? By multiplying two. By multiplying what? Remember perfect squares? How do we get perfect squares? Like 4, 25, 100, and so forth. How do we get perfect square? How do you get perfect squares? You multiply two of the same numbers, don't you? Hello? So how do we get perfect square trinomial? Raise your hand. Anybody remember? Uh-oh. Okay. How do we get perfect squares? Like 4. How do we get 4? 2 times 2. How do we get 16? How do you get 25?
5 times 5.
Right? So you get 2 squared, you get 4. 3 squared, you get 9. 4 squared. So how do you get perfect square trinomial? Yes, sir. Yeah, it's the binomial square, a plus b squared, right? When you have a plus b quantity squared, what do you get? Yeah.
A squared plus 2ab plus b squared.
Yeah, exactly. That's what a perfect square is. Remember? You guys remember that? That's what perfect square trinomial is. Now, do I have to have a plus b squared? Could I also have a minus b squared? That's another binomial, right? What do you get when you then multiply a minus b squared? Are you writing this down? Okay. Who remembers? One person? The same person? Come on. You guys know what we get, right? Chris.
A squared plus 2ab plus 6.
A squared plus 2ab for minus is correct. Very good. You guys remember this? So we're reviewing a little bit, right? Perfect square trinomial. You get that by squaring a binomial. If it's a plus b, you get, remember you get the two of the same linear terms, right? And if you have a minus b, oh, by the way, why is this plus right here? Why is this plus b squared? Shouldn't this be negative b squared? Yeah, minus.
When you multiply the two b's together, they're both negative.
That's right. When you multiply negative b times negative b, this becomes, right, positive. So look, everything looks the same except the middle term, right? Middle term, you have 2ab here, you get minus 2ab. You guys remember this? Okay. So that's how, and then PST factors as squares of binomials, right? We learned that. What about difference of square? What if I have a squared minus b squared? How does that factor? What do we get when you factor a squared minus b squared? Everyone should know. Come on. One person? Come on, I know that. Aaron. Exactly. A plus b times a minus b. So knowing these will help us now factor polynomials with 4 terms that happens to have 3 of those terms happens to be what? Hello? Okay. Yeah. Perfect square trinomial. Right. That's how we. So if you recognize that 3 of the terms is perfect square trinomial, right? This is what we're going to be working on today. Very good. Okay, so type 1, you have a squared plus 2ab plus b squared minus d squared. I call this type 1 because look at the first 3 terms. What do you see, class? Yeah. You see perfect square trinomials, don't you? So that's why I called it a type 1. Guess what type 2 is then? Because I have type 1 and type 2. Type 2 will be, we talked about this before. Anybody want to guess? Yeah. Oh, no. So these are the one with 4 terms. Oh, we'll get there. Don't worry about it. Okay, so first, so how should we group them then? We should group the first what? 3 terms because that's your perfect square trinomial. Hello? So could we do it this way? Yes? I group the first 3 terms. What do I get when I group those 3? How does that factor that trinomial? Because this is a PST. Yes, sir? One person? Come on. Same person. 2, 3. William?
A plus B squared.
A plus B squared. Isn't that what we just talked about? Right? That's a perfect square trinomial. Therefore, it factors as A plus B the whole thing squared. Now, what do you have, guys? Yes. The difference of square is correct. What is your A this time? Yes. A plus B. What's your B for this difference? Yes, Sarah? D. So doesn't this become something plus something times something minus something? Right? So who can tell me what I get when I do this? This is nothing more than a difference of square. Stefan, tell me what I get.
A plus, or parentheses, A plus B plus D
Uh-huh.
times A plus B minus D.
Exactly right. Very good. And of course, because, something minus something times something plus something, right? Should I leave it this way or should I get rid of that parentheses inside the parentheses? At the end, when you simplify, you should get rid of those, right? So what do I get when I get rid of those? What's really in front of these parentheses? In front of them. A plus B. There's really 1. So when you distribute 1, don't you get the same thing? So what do I get? Flat?
A plus B minus 3 times A plus B.
That's exactly right. Any question? By the way, has anybody figured out why I call this DNA onion problem? Remember, DNA tells you who your biological mother and father is. Has anybody want to figure this out? Sarah, what do you think I called it DNA?
Because A plus B comes from the trinomial, so it's like DNA and then
Yeah, that middle term tells you your mother and your father right here. See? That's how you know that you need to get, you know what I mean? That 2AB tells you which 3 terms together, right? That's your middle term, you know the A. And do I need D for that trinomial to be a perfect square trinomial? No, D is not involved. You see that, that tells you, that's your DNA. I don't know. Okay, if you don't like that, you don't have to go. But anyway, so, and of course, after you do DNA, you get onion because you're DS, right? You get, after you do this, don't you get the onion problem? You have to factor again, right? Does that make sense? Anyway, so guess this is type 1. Okay. Guess what type 2 is? Okay, type 2 is this. How is this different? Why do you think how is this type 1 and type 2 different? This time, what's the difference? Eddie, do you see the difference? D is in front. In other words, your perfect square. Do I group the first 3 or the last 3 terms? This time I group the last 3 terms. Remember we did this before, haven't we? Okay, so how do I group the last 3 terms? Anybody? Do I just put the parentheses like this? Can I just put the parentheses around the last 3 terms? No, I wrote down wrong. Why? Isn't that what we do? Can we just group the last 3 this way? What's wrong with this? That's fine, right? Obviously no. Why not? Anybody see why this would be wrong? If I just blindly put the parentheses on the last 3 terms. Chris, why is this wrong?
Should be negative 2A plus.
Oh, it should be this way, you think? Why do I have to rewrite? Didn't we have positive 2AB? Why is it now negative? Didn't we have negative B squared? Why is it now positive? And then this A squared, wasn't it really negative A squared plus negative A, right? Why is it now positive A squared? Why does the whole 3 terms becomes this opposite? Why do I have to do this? See it? Yeah, because if you think about it, what does this mean? You have to distribute this negative 1 3 out the whole 3 terms, right? If I do, then look, I think I have it somewhere. So here's how I could check. Doesn't this really mean D squared plus negative 1 times this whole thing? When I distribute, don't I get this original one? Otherwise, right, I would not get negative 2A squared plus 2AB minus B squared. Does that make sense? Hello? In other words, do we have associative property for subtraction? No, it's a subtraction here. You can't just put, right, parentheses around. You have to be careful when you do that, right? If you wanted to, you could make everything to addition and like this. You could make everything to addition. Somebody said, well, why not make everything to addition? Then group the last three, then factor out a -1. Isn't that what we're really doing? Do you see what I'm saying here? Okay, you could do that if you wanted to. You could make everything to addition, put a parenthesis around the last three terms, because you could use the associative property of addition, right? Then factor out a -1. You get the same result, right? So here I'm kind of skipping some steps here. Isn't that right? So this is what we have so far. Are we good? D squared minus, in parentheses, a squared minus 2ab plus b squared. So type 2, you have to be careful, right? When you group the last three, right? You got to factor out a -1 from those three terms. Otherwise, it won't be correct, right? Ryan?
If you distributed the -1, why do you keep it as negative? Why do you keep d squared? I mean, d squared minus d squared.
Do you think this should be d squared plus?
I'm not sure that's
Well, you could write it as d squared plus. It's d squared plus -1 times this trinomial. If you don't believe me, like I said, check it, multiply it back. You see, if you multiply it back, right, don't you get the original, right? Okay, then, what do you recognize? The last three term is your, yes, PST. Who could tell me what that becomes? How is that factor? One person, 2, 3, 4. 4. Austin? A squared minus 2ab plus b squared. We could just do it on the side if you want, okay? How many ways are there to get a squared? One, so it's a and a, right? How many ways are there to get b squared? One, which is b and b. Now, do you think it'll be like this, or do you think I need, see, look, I have -2ab, so what do you think I need? What? I need a plus -b times a plus -b again, don't I? In order to get -2ab, look, if you don't believe me, here, do this, a squared, right? Do this, what's negative times negative? So that's why we get positive b squared. Here you get -2ab, and then here -2ab, I mean -ab, you have two of those, so you have -2ab. Right? So what does that trinomial become? When you factor it, we just factor it. What's that? What's this?
A squared minus 2ab plus b squared.
Yeah, which is, well, we want to factor this trinomial, right? What do you get when you factor this trinomial? We just factored it. What's your end result when you factor? A minus b times a minus b times a minus b, right? Yeah, a minus b times a minus b. Could I just write a minus b squared? Because isn't that's why, because we want to see that, you see, it's going to be difference of square, you see? So we get difference of square. Does that make sense? That's why we like this perfect square trinomial, right? Because then it leads us to the difference of squares. So what's your a this time? Your a is class. What's your a in this? D. What's your b? A minus b. Okay. Somebody tell me what to write then. It's going to be. Isn't this going to be something plus something times what? Something what? Minus something. In other words, a plus b times a minus b. So we just said a is d, b is a minus b. Somebody tell me what to write then. Yes.
D plus parentheses a minus b
Mhm.
times d minus parentheses a minus b.
Exactly. Everybody okay with that? You see how I just plugged it in, a and b? Just substitution here, right? Who could tell me how to simplify this now? I don't want to leave a bunch of parentheses like this. Who could tell me? What does the first term become? I mean, first factor. How do I simplify this? Anybody? Yes. D plus a minus b times what? D minus a minus b? No. Uh-oh, that's how you get it wrong. Remember I told you. Yes, Chris? Plus b. Why is it plus b, Chris? Yeah, don't you have to distribute this negative inside, right? Look, there isn't this plus -1 times this whole thing? Right? What's -1 times a, guys? Hello? What's -1 times negative a? What's -1 times negative b? So don't forget, a lot of times people do like 99% of the work,